right, this question is a little bit different from the rest of them, okay? One thing that you're gonna have to notice right away is that we're talking about change. In other words, if I change one variable, how will it affect how the other variable changes? When that happens, you automatically know it has to be either formula 3, 4, or 5, because they deal with in relation to one variable. If I change it, how will that affect the other variable? Only formulas 3, 4, or 5 have a beginning side, side 1, and an ending side. How do things end up, side 2? So again, it either has to be 3, 4, or 5 whenever you're talking about something changing instead of just calculating something as it is. All right, let's read the question and figure out why it's a little bit bigger, okay, to deal with. It says, when measured at standard temperature and pressure, that right there is why it's a little bit bigger, because they can just say standard temperature and pressure without giving you any more context and expect you to automatically know these things that are written right here. We'll get right back to those. Let's start reading the question again. When measured at standard temperature and pressure, STP, a gas was found to have a volume of 500 liters. What volume will it occupy at 0 degrees Celsius and 93.3 kPa of pressure? kPa is a unit of pressure, just like ATM is a unit of pressure, the more common one you will see. And then also torr, spelled T-O-R-R, is a unit of pressure, okay? All right, so that might be a little distracting for you to finally see that kPa being used to represent pressure, okay? So once you realize it's a formula that, you need a formula that represents variables changing, you know it's either 3, 4, or 5, the next best thing to do is to say, what does the question talk about, okay? Well, it's talking about temperature and pressure up there, it's talking about volume here, okay? So we have a volume here that it's talking about, and we want to know what volume it will become, so we have a volume 1 and a volume 2, okay? All right, if the temperature goes to 0 degrees Celsius, and that's a temperature, okay? All right, so we have the temperature here, the standard temperature, and then we have the temperature that it goes to. Don't assume that they're different, but it's still temperature 1 and temperature 2, okay? All right, and we're saying at a pressure of 93.3 kPa. All right, so in the standard temperature and pressure, we have a pressure. So that's pressure 1, and then we have what happens, we have the new pressure, all right, which is pressure 2. So then we have temperature, volume, and pressure, okay? All right, so I came out over here and I wrote that down. At the start and at the end, we know the temperature, pressure, and volume. The temperature, pressure, and volume. The most obvious ones are the ones written out in the question, okay? How did we end, okay? We ended with a pressure of 93.3, so I wrote that out over there. And we ended with a temperature of 0 degrees Celsius, so I wrote that out over there. And we are trying to calculate the new volume. Now, is there something else I want to point out? Okay, I think we're flowing pretty smoothly. All right, so what temperature did we start with? What pressure did we start with? What volume did we start with? They didn't tell us in the question. Wrong. Remember I told you, if they say standard temperature and pressure is what we started with, they expect you to already know what that means, okay? So I wrote out to the side what the standard temperature and pressure could be. I also wrote out what moles would be and what volume would be in that instance if you needed it, but it's not talked about in the question, so we'll just focus on temperature and pressure. Under the condition of standard temperature and pressure, okay, your temperature is always going to be either 273 degrees Kelvin, which is the same thing as 0 degrees Celsius, and your pressure is going to be 101.3 kPa, or if you're using torr units, it would be 760. If you're using ATM units, it would be 1, okay? All right, so how am I going to decide which unit to use for temperature and which unit to use for pressure so I know which number from the standard to copy over for the starting temperature and pressure? Well, I want to use whatever unit they're using at the end in the question. So since for temperature they use Celsius, I will use the standard temperature in Celsius instead of Kelvin. So then I have 0 degrees Celsius. I'm sorry, I kind of want to be consistent with these colors. All right, it doesn't always mean something, but it just feels right. All right, 0 degrees Celsius. All right. All right, and then the pressure, standard pressure. All right, I could either use kPa, torr, or atm. How do I know what to use? Well, the question used kPa. So then I'm going to pick the standard that matches kPa, which is 101.3. Okay. And the original volume, okay, let's see. The original volume was given in the question, 500 liters. Okay. All right. Now here's a secret. Anytime two, okay, are not actually changing, okay? So notice they told us we had standard temperature in the beginning, which is, if we're talking about Celsius, 0. They told us at the end it was still at 0. Anytime that number doesn't change from one of the variables and you're dealing with a formula where all the other variables do change, you can cross that right on out. You do not need it. Okay? All right. So you're going to see I did choose the big formula because there was no formula there was no other formula between 3, 4, and 5 that had all the variables that I dealt with. So I chose that big formula. Here's what I can do. If it's not talked about in the question, I can just cross it out of that big formula. Okay? Additionally, if it doesn't change in the question while the others do change, I can also cross that out of my formula. Okay? All right, so where I plugged it in as 0 and 0, I did not even have to do that because again, if the variable is the same variable and it doesn't change, I don't need it in my formula. Okay? So the first one I crossed out the moles because it wasn't even talked about. Okay? The second one I crossed out only because it was the same, it didn't change when the other ones did change. So then I'm kind of left with a formula that looks like Formula 3, all right? But just to make sure you know how to deal with it in the combined gas law formula, Formula 5, I went ahead and I showed you that. So once I get rid of that temperature because it doesn't change, then all I'm left with is 101.3, okay, which is the first pressure. That's the first pressure. All right, times 500, which is the first volume, is equal to the second pressure, which is 93.3 kPa, okay, times the thing that we're looking for, okay? So the thing that we're looking for, I don't want to know what it equals times 93.3. I just want to know what it equals. So how do I get rid of that times 93.3? I come over here to the other side and write the opposite symbol, which is a division symbol. Since it's being multiplied, that's how I get rid of it. I divide, and I do it on the bottom of the opposite side. So divided by 93.3. Okay. Make no mistake, when you get here, okay, this 93.3 right here is gone. That question mark is equal to this 101.3 times 500 divided by 93.3.